Should be seeing my screen now. So here's my talk today, like my workshop today, which is Unreal Engine Introduction and Blueprint Communication. So yes, let's get right into it. Quick background about me. I'm an indie game developer from Nigeria, Ile-Ife, Osun State to be precise. I'm a final year student of computer engineering at Obafemi Awolowo University, Ile-Ife, Nigeria. I discovered my passion for games in 2017, my first year in university. I've worked on mobile PC titles, COVID Run, Skippy Ride, to name a few. All in Unreal Engine. I'm currently working on two interesting titles with Dimension 11 and Avalon. I'm working on Lens of ORISHA, Blood and Water with Dimension 11, and an interesting title which is still under NDA with Avalon Cup, all as an Unreal Engine programmer. I love to play the trumpet games to have fun when I'm not developing games. Let's get right into what we have for today. Sorry for putting 4 on top of the Unreal Engine. We're currently in UE5, so let's just take note of that. So this is just to showcase like the logo of the software. So we're not using Unreal Engine 4 in today's workshop. We'll be using Unreal Engine 5. So take note. Unreal Engine, a software, a tool that was developed by Epic Games, which is a big game company in the US that has worked on very popular titles, Unreal Tournament, Fortnite, and a couple other interesting titles. So about Unreal Engine, right, is a free real-time interactive 3D creation tool. First released, that was Unreal Engine 1 on 22nd of May 1998. That's gone through series of iterations, through series of versions up until this year when UE5 was officially released and was out of beta. So it has been used to make popular titles, some of which some watching this stream would know. Fortnite, Hellblade Senua Saga, Hellblade Sacrifice, Sea of Thieves, Plus 2022, Black Myth Wukong, so many titles. And many titles are still being developed. This game engine has been adopted by both indie studios, like individuals, developers like myself, and mid-range studios, like studios with average budget, and AAA studios, studios with very, very big budget. So the game engine is a very big one and used across the board. Features of the engine, right? Like, let's talk about the industries where Unreal Engine is being used. It's being used in games, like I already mentioned that from the previous slide, to make interesting, game titles. Used in films and TV, like for example, what's the now this the Magdalorian? Yeah, I almost forgot that. So that was made. Some part of the capturing, recording was done using Unreal Engine in a studio, using real time feature of the game engine. Architecture, Unreal Engine supports architecture, like the framework there has features that can be used in the architecture industry. There's Twinmotion, which is owned by Epic, that integrates well with Unreal now, and so many other tools available for you, Datasmith, and so many pipeline tools that you can use for architecture. Automobile and transport, with the product configuration feature, you can really create vehicles for showcase, for customization, customize the parts and show it with hyper-realism, like looking at very real, as though it was a vehicle that was manufactured. Simulation, like these involve scientific and non-scientific simulations, like if people simulate physics, real world activities in the game engine, and people also use it for water simulation, fire simulation, like it has features like the one with the Niagara particle effect system in Unreal, can be used for so many kinds of particle simulations and cloth simulation, so many things when it comes to simulation. Then broadcast and live events, virtual production now. Like folks that are working on the broadcast industry, like for they call the feature end display, where you can have screens behind presenters, and they can cast displays on those screens using the Unreal Engine, and to feel as though they're actually there, like to bring realism to that. And so many others that I won't be mentioning today, but you can go and look out for them on the internet. I didn't mention the education space, which is another important use case of Unreal Engine. Works in education for edutainment, educational games and things like that. Healthcare, aviation, and military, aerospace. So many application areas. Engineering as well. So it has been used in making different titles. Before I continue, just to mention, our focus today is on the first one, which is games. Although if you are from other industries, this workshop will still benefit you as well. So you can tag along with us as we continue on this. And to mention, every question will come in at the end of my presentation, like my workshop, and I will do well to answer as much as I can. So yeah, the engine has been used to develop, is used in making titles for different platforms. Support PC development, mobile. I say PC now. Support Windows and the iOS. I don't see support for Linux. Probably there is, but the popular support I see is for the Windows and iOS. That's the Mac OS rather. Sorry, not iOS. Then mobile, that's Android, iOS, console, Xbox, PlayStation, Nintendo, VR and AR devices. So it's used across the board. It supports so many devices. And that's one of the reasons why it's so popular, because you can make a game in one place and port it to so many platforms. So that's why you can have cross-platform games being made with Unreal Engine, because the architecture and the framework of the engine supports multiple platform shipping, so you can ship to multiple platforms. The main programming language used is C++, and it has built-in visual scripting language called Blueprint. I think Blueprint is a lot popular nowadays. So, and that's what we'll be using for today's demo, because it's very, very easy to use, and you can easily do demonstration and prototypes quickly with Blueprints, which won't require some compile times and stuff like that. But knowledge of C++ is also very, very important, especially if you are going on the gameplay programming route. It's used in games for making 3D games, yeah. You can, in brackets, you can actually use to make 2D games, but it's not, the support for 2D games is not so robust, the features for 2D games. So most titles you'll see being made with Unreal are 3D games, because it does it so well. But you can see it to create 2D games. There's a new feature in Unreal 5 called Paper ZD, if I'm correct, which is an upgrade to Paper 2D from the previous version that supports 2D game development. So yeah, and Unreal has a strong community, right, and developer support. So when you have issues, you can easily get help, because using a very robust and big tool like this, you could have issues easily. So just note that knowledge of Unreal Engine, like using Unreal Engine, you can easily reach out. Like there are forums and Discord platforms where you can, ping fellow developers and even Epic staff themselves, and they'll come in to give you support. If you find a bug, find issues, there will probably be someone who has something similar that can come into help. And it has a lot of awesome tutorials to learn fast. Like if you go on YouTube, go on Udemy, go on Coursera, you see beginner level tutorials, and so much is available for Unreal Engine out there for you to start learning. So it's always very easy to get started. Like it's well supported. And one final thing, which is like an addition, is Unreal Engine gives you freebies, right? Epic Games give you freebies, almost everything for free. Like the very, very big robust engine is given to you for free to use to make your games. And they release so many assets, like models, 3D models, animations, and all that kind of stuff for you to use for free, even to ship your games. So even every month there's this free for the month assets where they release a couple number of assets from the marketplace for free for you to use, and you can use them in your games and still market them. So you won't have to pay for them. But to mention, they collect royalties when your I think net sale crosses $1 million. So once your game makes above $1 million, then I think is it 10% or 20%? I'm not sure of the actual figure, but a certain percentage of royalty Epic Games collect when your game makes a lot of money. So they are well there to support developers. So if your game doesn't make that much, then you get all your money, from your game sale. Yeah, to the next slide. Now let's go to Unreal Engine proper. So Unreal Engine is like a book of ingredients, right? Like not a recipe book now. I mean, with Unreal Engine, there are so many ingredients available to you. So it's left for you as a developer to mix things together and create something very beautiful. So Unreal Engine will not tell you, oh, do it this way. Like Unreal Engine will tell you, oh, we have these options available. How do you want to do it? So it allows developers, game developers now to be very, very creative to make things that they want to make. Like they don't limit you. They give you everything, like very robust tools. So take note of that. So components of the Unreal Engine. I'm going to release my slide out so that some of these links that are here, I won't be clicking on them, but they explain more on some of the things I have listed here. So components of the Unreal Engine, it has the sound engine, which is like the system the system working in Unreal Engine that handles your sound, meta sound cues, audio equalizers, like everything that relates to sound really is being handled by the sound system, the sound engine in Unreal. Then there's the physics system. I mean, every game engine should have a physics system that handles physics, like things that has to do with gravity, weight, collisions, interactions, things that have to do with force, impulse, anything that simulate the physical world in Unreal that makes it look realistic. Is being handled by the physics engine. Then the graphics engine handles what is being displayed finally, like the rendering of every computation that has happened in the engine. So it supports OpenGL, I think Vulkan, and several other graphics APIs. So these are backend stuff that Unreal Engine abstracts for you so that you don't get to interact with those directly. Unreal Engine does all the heavy lifting for you, that you only have to just build what you want to build, front end, be very creative, and the graphics engine knows what to do with them. And you're able to see things in real time as well. So things like light and shadows, post-process effects, you see them. I mean, the graphics engine will do those. The inputs and gameplay framework, things that has to do with AI and player interactions, mechanics, that's where core programming comes in and blueprint scripting. So Unreal Engine has a gameplay framework. I won't be talking much about input and gameplay framework here. Maybe I'll do a little in the demo, but it's a very, very important feature of the Unreal Engine. And the understanding of the Unreal Engine gameplay framework allows you to see how the Unreal Engine is structured and how you can best utilize structure of Unreal Engine, which the structure is built on inheritance, just to mention. And then we have the network multiplayer and multi-platform capabilities. I mentioned that Unreal Engine supports multiple platforms, and the component of the engine that handles cross-platform porting is there for you. The networking, you want to create multiplayer games that multiple individuals can connect and play in real time and interact and communicate as well. Unreal Engine has that feature available for you if you want that in your game. And up to the next slide. I'm going to do a quick demo now. Creating an Unreal Engine project, and we'll go from there. So I'll explain the interface in Unreal Engine and do a demo of events, functions, and methods. I won't be working with a blank project here because of the short time I have for this presentation. So I would just use a template the Unreal Engine gives you to do my demo. Let me open our Epic Games launcher. So to launch your Unreal Engine after installation, for this, I won't be extending installation here as well because Unreal Engine is quite heavy and it takes a lot of time to install. So I won't be talking about that here. I would have to sign in. Can I remember that? Oh, I should have signed in dog shaped cookie. This shouldn't take me time. With long hair. Cats with long hair. Sorry about this. Epic Games does this sometime. I mean, I should be in a moment. So once the Epic Games launcher launches, once you're in the launcher environment, then you can run your Unreal Engine from there. So let's just do the second. I hope this doesn't take forever. Hmm. If it doesn't open up, let me just try the faster alternative route in the interim. So that, okay, yeah, it's up already. So once you're in the launcher, well, the Unreal Engine is loading up in the background. Once you're in the launcher, you go to Unreal Engine, and then Unreal Engine opens up. And once it's open, you go to your library. Your library, oh, I closed it. Let me just close it up and open the launcher again. Yeah, so you go to your library and then you launch Unreal Engine. I think there's a bug here. Okay, yeah, it worked. I don't know what bug that is. I don't know, but yeah. So this interface comes up for you. So you go to games, and then you can pick a blank project. You can pick first person, third person, whichever one. So I love to use third person for demo because it it gives more perspective. Like it has those some functionalities in already for you, so it's very easy to work with. So, let me just do Africa. Don't want a very long name. Communicate demo. Oh, yeah. Hopefully this is not too long. You select blueprint because we're working on blueprint here, and then leave every other thing as default. And then you run. So it creates your project for you in a couple seconds. Shouldn't take so long. Shouldn't take forever. And just to mention, like there are two ways of installing Unreal Engine. You can either install the binary file through the launcher or install from source, depending on what level of programming you are. I think if you're still like learning and working on very basic projects, you might get away with running Unreal Engine directly from the launcher, like installing Unreal Engine from your launcher. But once you want to do some more low-level stuff like doing more C++, then having Unreal Engine from source, that's like from their GitHub source. So you're getting like latest version of Unreal Engine, not the main version now that is windowed, like not the launcher version now, but the source code version that is being updated from time to time. So just know that. But for this one, we'll use the launcher version and not the source code version. So this is what Unreal Engine gives you once you go with third person. It gives you a third person interface. And once you look at the interface, it's segmented into parts, right? This base part, am I frozen? Okay, yeah, I'm back. I thought I was frozen for a moment. So this base part is the content browser, and this is where your directories are located. So the assets you use in Unreal, you can just navigate to them from here, and then everything that has to do with your models, your animations. I think I'm skipping. Okay. Okay, I'm back. So everything that's to do with your models, your animations, and everything comes in here for you. So you can easily drag things into your level. For example, if you go to meshes, you can drag in skeletal mesh to your level if you so wish, if you need to work with that. And this is just available for you to navigate to select assets like that you need for your game. And by your right, top right, that's your word outliner. So every asset that has been placed in your level can be selected from here. So this gives you access to the items in your level, basically, like the actors in your level. So with selecting assets from here, like your actors from here, once you double tap them, it takes you to them like a close-up view. So if you're working with a very large world and you need to select just one thing, you can come here and do a search, maybe RAM 2, and then you can select it and to zoom in up close to it. So it makes it very easy, rather than you navigating with your mouse and moving around to select them. So take note of that. And the top part is your menu bar. That's where you have your file, your edits, your windows. These are things that I would advise to play with, because I can't go through every one of this in just an hour. It's so much. But over time, when you use Unreal Engine, you get familiar with them and you can use them as you wish, as you want. And there are different modes in Unreal. Right now, we're using select mode. If you do level design, like if you're designing your level, you can come to landscape mode, where you can build out levels. If you do, if you want to with paint, or paint your level, like you want to probably mark some part of your level for certain things, then you can use that. I don't really use much of other stuff. Fracture is when you want to like do what's the name now? If you want to do destruction for meshes and assets in your level, you want to break things and you want them to break in a certain way. Although it can be quite expensive, but that works for that. Brush editing, still more of level animation. This works for items in your level that you want animated. Many of the features I personally don't use often. So the one I really use is the select option, which just allows me to navigate through the level normally and see things and move around. Yeah, so that's that. And then the large area we are all seeing is the large area we are all seeing. Am I still here? I hope I am. So the large area we are all seeing is the viewport. That's where you view what you are, handling in your level, like everything that is within the level. You can move around, navigate, and allows you to just see them and move through them. So when it comes to controls for navigating, there are different ways in which you can navigate on Unreal Engine. You can use you can hold down your right mouse button and use the Q and and E, Q and E to move up and down, Q and E to move up and down, then A and D to move left and right, and W and S move forward and backward in your viewing direction. So with these controls, holding down the right mouse button, you can easily navigate the level. So with your middle mouse button, you can pan around like vertically and horizontally, like you can pan up and down, pan left and right with your holding down your middle mouse button. And the other ways to control Unreal Engine, but these are like the common ways and I think the easiest to use. And this is the one that I personally adopted when I'm working. Yeah, so now let me just go to the next part, which is like from my slide, which is creating, give me a second, which is explaining the Unreal Engine interface. I've done that. Then demo blueprint, that's event functions and methods. So to demo blueprint, event functions and methods, I would go to the player class. So there's a class that handles your main character, and that's a player class. So in this template project, if you go on that third person and you go on that blueprints, well, the things I'm saying now, that is that you can do on your own if you have Unreal Engine installed. If you use the same template I'm using, which is third person. So if you go on that third person character, BP third person character, and you open it up. So it's open, but somewhere else. Let me bring it to my main viewport. Yeah. So if you open it up, it gives you this interface, and this is your blueprint editor. Inside your blueprint editor, this is where you most likely be doing your mechanics. If you are not using C++, you are using Blueprint. So this is where your mechanics would come in. And it's good to familiarize yourself with this interface, because even when you do C++, you still do some Blueprint and you need to use this interface. So this interface is divided into different parts. The top part, which still remains like we had before, the file edit. Then we have the next part that follows, that's switching tabs. The next part that comes after that is where you have some of the functionalities for your blueprint editor. If you want to compile, you hit the compile, and then once you hit it, once it shows you green, it shows that there was a successful compilation. For example, let me just try to do something very, very stupid. Let me see. I'm trying to just create an error here. And I'm thinking, let me see. Let's work that way. Don't worry, I know whether that will bring error into this. Imagine I'm on live stream and I don't know how to cause problem in a real editor. So yeah, this for compile. If you want to save, it's save here. So if you want to browse to where this particular blueprint class is in your directory, it's browse. It takes you where it takes you to where it is in your content browser. So this is a secondary content browser. You can have more than one. This is the main content browser that is existing here. That's your content browser one. This is your second one. You can have more than one content browser so that you can just navigate through. But nowadays you can have content browser inside of blueprint classes, so you can easily move, if you want to move assets into your blueprint components directly, you can always do that. So to take note. But I don't work with this here because it takes more, screen space, and I don't like it, so I leave it down. And then this is for source control to diff. You want to diff a blueprint class against the version of it that exists in your source or a previous version. Use your diff. Find, I think that's if you want to find certain classes, nodes, blueprint functions within your projects. Firstly, within the directory, you use this. Class settings are default settings that relates to your class. They come here. Class defaults are like default attributes to your class that have been exposed. Even attributes that are on on your player, the things you are seeing here are things that are inherited. That's why you are seeing all of these here. These are like attributes that were implemented in C++ because we are using a template project that inherits from C++. So these are things that have been displayed here. So the class defaults are here. So once you create a default, for example, let me create a default variable. Let me say open door or something, and then I expose it here and I compile. If I go to class defaults, I should find it here. When I click on open door, it's a default. So anything that you expose that is like a default class, attribute of your class stays there. And simulation, like in your viewport, if you are working with anything simulation, like probably you brought in Niagara or certain effects, I think even sound effects. If you want to do anything simulation and you don't want to do it, at the level, Does that make sense? Like if you don't do it to your level, but you want to do it at the blueprint class level, you can simulate here and view it and see how it works. And although I don't have anything to simulate it, so you can't see that here. And then play, that's if you want to play your level from here, it throws up another viewport for you so that you don't have to leave this particular point. So, and then yeah, pause, stop. These are things that you can use to just debug, to step through, each frame. Like if you have an issue probably with your first frame, you can use that to, this stores are just for probably debugging, and I don't really use them. I just play. So, but I think it's for debugging option. This one too is for debugging. Like when you run your game, you can debug probably your character and then see how the blueprint nodes are being executed, how things are running. So yeah, and on the left side you have your components. So these are components are like with the way the Unreal Engine is structured, a class is made up of components. Like a class does not exist without components. So it's where you have multiple components that are interacting that you have a class. Multiple components and attributes and functions coming together gives you a class in Unreal. So we can have, let's say your player class, we have capsule components that handles collision. We have mesh components, that's your mesh components that handles that holds the avatar. That's like the mesh of your player that every other player sees or that exists in the world. So what is actually visible representing your character. The arrow component, they use it for like certain maths computation to show direction. Is it facing forward? Is it facing right? Facing left? Camera component, you know what that does? It's like the player eyes in the world. So use it to pan, move around in the world. So without that, you won't see your player. So in the camera to view what your player is seeing. So that camera does things when you want third person view, first person view, and all that kind of stuff. Then coming down here, you have graphs. So you can have multiple graphs in your blueprint class. Like I have event graph. You can create even a new graph. Let me say Davis graph, for example. And I want functionalities to be here. I just bring them here. So like now, if you look at this graph, these functionalities are here. So inside David's graph, other functionalities are here. So I wanted to note that some particular execution nodes, I just showed that can only exist inside one graph. Like your events can only exist in a particular graph. You can't have, because you have multiple graphs, doesn't mean that you can have that kind of event in multiple places because it's still one blueprint class. So there surely be a single entry to that event to perform every other functionalities that have been tied to the event. But let me just explain what events are. Events are like entry points for you to perform certain functionalities. So, like for example, if I click on custom events, that's how you create an event. Custom events, let's say queue player, for example. So with queue player, you can attach execution nodes to queue player to, let's say, anything you want to happen when you queue player. So if you want to queue player, all you have to just do is to call queue player, and then calling this function, which is the entry point to performing killing functionalities, basically, if that makes sense. Yeah, and then down here you have functions under new graphs. So you have functions, and mind you, all your events in a particular graph appears as smaller. I mean, they are stacked up, so you can go through and see what events you have there. So you can see that I added kill player to David's graph that I just created, and it's already here. So I can easily go through and navigate and select them easily. Then you have functions. Functions are like bunch of executions, like a bunch of commands that you can execute to perform certain functionality. Like they will advise you to make functions to have, they call it single responsibility. Is a principle in computer science where a function should just do one thing. You should not have a function that is killing the player, that is restarting the player, that is, everything is all messed up. So when you need to perform one and not the other, you won't now want to start, splitting things somewhere and have that. So you should have a function that does just one thing. The function that can, in fact, even kill player is still very generic. If you want to break it down, like maybe spawn particle effect to kill player, then play sound, the more modular, the better, I would say. So functions should have unique responsibility, like single responsibility. So, and there's a particular function that comes for you by default when you open Blueprint classes. That's the construction script. If you're familiar with the concept of OOP, that's in C++, you know the called constructor. Constructors are like functions that carry your class names. So what they do basically is they initialize the instance of a class. So when the class instance is being created, the initialization happens on the constructor. So anything you want to be done at the initialization point of your class, you put them in your constructor. So in Blueprint, it becomes more interesting that if you want to do things at level time, like before you run your game, you want to see things happen, interactions and basic level design utilities while you're staying in your level, you can put them in your construction script and you'll be able to work with them. Just note that this construction script is very, very useful for things like that. And things that you want, default values you want to be set, variables you want to be set before you begin your game, you put them in your construction script. And yeah, and you'll be advised not to put very heavy computation in your construction script because it's very, very expensive. So that means that the class will not be initialized until those things are performed. So you want something too heavy to be attached to your construction script. And down here you have variables which you can group into categories to allow easy access. So you can have open door now, I can add it to a category. You want to add a new category, come here, you change it from default to, let's say, door properties. So once you do that, if you come down here, you see that you can now add more. It just helps you group variables because variables don't all do the same thing. So if you want a set of variables that are doing a particular thing, you do that here. Like you use categories to group your variables. And this eyeball here, like I showed earlier, is to expose your variables to your level and to your default class properties or attributes. So with that, other classes can easily access them. So for example, if you spawn a particular class, the exposed variables can be easily accessed directly from there. And also on instances of that class, you see them appear when you expose them. But if they're not exposed, you cannot access them on their instance because they are not class defaults. So any exposed variable of a class will be exposed as a default for that class. And then down here we have event dispatcher. I won't go into it now because I'll be doing a demo on it. I have very short time left, but I'll see how far I can go with this. So you have local variables, which are variables. We're in the construction script, so a local variable will appear. But if you're at your event graph level, you won't see local variables. So local variables are variables that their lifetime is the lifetime of a function. So they are variables that you can use to perform function-wise computation. So for example, when you're in the function that opens the open doors, I want probably a door angle, you want probably door angle floats to exist, but you don't want other parts of your class to know about it. You just want only the function to do stuff with it and dispose it off. So you do that within using your local variables to do that. So they are like, they call them in C++, if you're working with programming, they call them what's the name now? Trying to remember. So they call them is it attributes of a method? Like I can't remember that, but I know that for sure. So that's that. And on the right side, you have your details panel, like where every detail of everything you select appears. So more information about it. So it contains attributes you can set, like values you can change, things you can edit. So when it comes to each component and even on events, it just gives you more, so to work with. Yeah, so that's about this first section. Going back to my slide, I'll go to the next topic, which is blueprint communication. So I will try to be fast with this. Like, I have to go quickly because of time. This is a very important aspect of Unreal. You go to blueprint communication, it involves the interaction, communication, and connection between different classes, components, actors, and systems in Unreal. So it deals with how data flows and how events are being called, the chain of communication in your entire game application, inside of Unreal. Like, how do classes talk to each other? How do they know, okay, this one has changed, so I should change, this one needs this value to update. How does it get it? So that's where blueprint communication comes in. So we have three options. We have direct communication, also popularly known as casting. We have a blueprint interface and event dispatchers. So direct communication, when to use it. So when you know the following already, you know the sending object. So like the class that is sending the information, like class that is making the call, right? Like the class that wants to talk to the other class. I think that's a way to say it. Like, that's an easy way to say it. And then you have the receiving object. That's like the class that is being spoken to, the listening class. The class that is giving the info and the class that is receiving the info. Once you know the two, then you can easily do a direct communication. So you can do casting. I might not go into use cases here because of time, but let me just use an example here. If you go to your capsule component, it will have a feature on it called component begin overlap. It's a particular event that gets called when your capsule component overlaps with anything in your level. So once you have this, right, whatever is being overlapped with will be given out to you as an output from that event. That event is just like, well, in C++, what happens on the background is, like behind the scene is, there's a function that binds to your physics component, like your collision component, that when it collides with anything, that function that is like this event is like a listening event, basically. So once that happens, immediately this event is triggered. So anything you want to tie to that, you will tie to component begin overlap. And I can show you a quick example. I'll quickly create a class called an actor class called maybe walkway. I'm not trying to implement functionalities here. This is just an example. So I'll put a sphere, a box collider here, a box collision. I'll make it quite big. I'll make it big. And then I'll put a box here as well. It's a cube. Yeah, just to showcase it in the world. So once you have this, for example, if you have this, then let me compile. So let me drop this in my level. This is very small. Sorry, I have to scale it up. What's happening here? Oh, yeah. So let me make it bigger. So you have a platform here, right? Let me drop the platform down. So you have a platform here, right? That has a box collision on it. So I'm not using the box collision for computation. I just want to have it there, basically. So once your capsule collides with this box, I want the capsule to basically do something. So I can just go on other actor. So once the collision happens, like these are the outputs you get. So what is happening behind the scene that you're not seeing is the actor that has been collided with is then passed into a particular variable that is passed to this particular output. So you cannot use a cast. Casting is a popular concept in programming that you want to check whether this particular thing that was collided with is of a particular class or is a particular type of actor. So I can cast to walkway. So once I cast to walkway, I want to print a string. You just use print string. And just print walkway. So with this now, once I play my game, my actor moves, and then I you see walkway appearing at the top. Maybe I'll delay it further. If I expand this and make this 10 seconds, so once I play this and then I jump on this, right? Walkway, you can see top there, walkway showing. So it is when you want to tie execution to, like, overlaps, or maybe you want to check whether something, an actor output, or not just even actors, like any class you have, you want to check whether the output coming out is of a particular class, and if it's of a particular class, you want to assess its functionalities and its properties. So use casting. Casting is quite expensive and is not advised, so you need to be careful of casting. And that's why, if I go back to my slide, I say sending, when sender gets a reference to the receiver, we have the reference to the receiver here. Like you said, that we have our other actor that was overlapped, so this is the receiver. So then you can use it. If casting successful, then the connection is complete. So if you could verify that that particular actor that was overlapped was of a particular class, then any functionality you tie to it, will be executed. And if it fails, then you can use the execution pin for cast field to do other things. So if it's not of this particular class, do this, basically. So that's casting. And there's more to casting, but I can't cover them in this particular session, maybe some other sessions. So we'll go to the next one, which is sorry, I'm going up and down, which is blueprint interface. Blueprint interface is another method of communication between blueprints. It's more or less like you're sending message and you're receiving message. Like you are sending information to someone and person receives it. Like I send a letter to A, I send a letter to B. So, but B is not really defined. You don't even really have to know what B is. You just send the letter, right? And then if B is actually very valid, then B does whatever is tied to it. Like, although you still need a reference to B, but you don't have to actually know whether B has implemented the interface. You don't need to know whether B actually has probably the decoder for decoding the message you are sending. You just send to B, believing that B would have the decoder. So that's like the kind of message I can give. You have encoded the message, you send it to B, you know who B is. So if B actually has the decoder, it will know what the message is and work with it as it should. So interfaces are very good. In fact, they're a lot better than casting, and they're a lot more efficient, because if B does not have what you need to decode, like doesn't know how to decode it, then there's no error. Nothing happens. Nothing is executed. Or like casting, where if casting can cause issues sometimes, although if your cast is successful, everything should be fine, but the performance overhead of casting, makes it not advisable. But with blueprint interface is a lot cleaner, a lot more cleaner, and you can do a lot more with it. So to create a blueprint interface, you come to your content browser and then you go to your blueprints, you see blueprint interface. Let me do actor as a character, or BPI player. Once you get an interface, an interface always has a particular owner, right? So in our own example here, we can put the interface on the player. So I can come to class settings, and you see this section called implemented interface, no interface. So you can add BPI player, and you see it there, and then you add it to him. So now your player is like the owner of the interface. So he's the one that can, receive the message. So he's a receiver of the message. Like anybody can send to him. So he's the one that has the code. So he implements the interface. He knows what he needs to decode the message that has been sent. So if I go to my interface and open it up, it's on that kind of blueprint graph. But this is a very special graph. It's not your usual graph. So here you can, let's say, for example, overlapped, overlap player. So I want an interface that gets called when I overlap my player. Although this is not a good use case, like you probably not won't do something like this in your game, but this is just like a demo. So once I do this and compile, when I go to my work, what's the name? my walkway actor, sorry, don't mind me, I lost mine. So once I come to my walkway actor, I select my volume and go down and on component begin overlap other actor. I won't do a cast now. I want to see whether my walkway will actually overlap my player. So I don't know. I add reference to the player. I don't know whether it's even a player or not. But I just want to just send my message. So if it's a player, then I want the player that you have overlapped me as a walkway, or I've overlapped you as a player. So I can call my function that's overlap player. Let me use overlap player. Yeah, so with this, I've sent my message. Now there's no caster here. I've just sent a message. That's how you see like a message box here. So coming to your player class, you can come under interfaces and you see that the particular function you added has been added to the player because your player now implements the interface. You can now right click and implement event. And I can print string now. Let me print string. Yeah, player overlapped. So once I print that string, like player overlapped, let me disconnect this. Let me come to David's graph. Yeah, let me disconnect this so that I can see this clearly. So once I come here and then I hit play, and then I jump on this, you see player overlapped. So I've established communication between this walkway and my player, but I didn't do a direct communication. Let's say I have another actor, right, that I can overlap. I can still do the same thing with the actor. If let's say I have an actor that I want my player to overlap with, I can still do the same thing. Nothing will break. I don't have to know who I'm sending it to, but the person I'm sending it to has to have a decoder, right, to decode the message I'm sending. So any class can call any class can call an interface, right? But the class you are calling interface on must actually implement that interface, unless nothing would happen. So if it doesn't implement interface, there won't be error, but you won't just see any results. So let's just note that about interfaces. Interfaces are like well advised for you to use because it allows you to have a cleaner, workflow for your development. And afterwards, we have the last one, which is event dispatcher. I might not be talking about this so much. Where's event dispatcher? Yeah, event dispatcher. So for event dispatcher, right, it's more like I'm sending an information out, but I didn't know who's going to receive it, but whoever can receive it should use it. So I don't need to know who's receiving, and that's something by event dispatcher. But the person that is receiving must know that I'm the one sending. So the sender doesn't have to know the receiver, but the receiver has to know the sender. That's something about event dispatcher. So there are use cases for event dispatcher where you just want a listener listening for something that once the owner of that thing does anything with it, the listener should update itself. So I'm going to quickly just do an example. This particular thing I did here for collision, I'm going to do it using an event dispatcher. So if I come to my character class, let me implement a dispatcher. Let me call it overlap player. Oh, overlap actor. Yeah, overlap player has been used actually somewhere else, so it won't allow me. So once I do overlap actor, let me do something. Once anything overlaps me, I want to call overlap actor. Call. So I call overlap actor. Now I'm done calling because I'm the one that has implemented it, right? So what I want to do is on my walkway, right? Once I begin my game, on my walkway, once I begin my game, I want to bind to my overlap actor. And how do I bind to my overlap actor? I need a reference. I told you that the sender does not need to know the receiver, but the receiver needs to know the sender. This is the receiver class, which is my walkway. But my player class doesn't need to know who whatever walkway is. It can just send out the message, and if walkway has anything about it, it responds. So, but my walkway needs to know my player. But I know that my player is actually the player character, like get player character, because it's his player I'm using. So I have a reference to him already. So I can bind overlap to show. Um, Let me look for overlap actor. Okay, I can bind overlap actor. Yeah, bind overlap actor. Um, Let me do castle. BP, third person BP. Yeah, bind overlap. You need a direct reference to him. So like you can't use, you have to cast first. So you need a direct reference. So once you do a binding to your overlap actor, so you can now attach an event to it, whereby you can have you can create a custom event and say, okay, on overlap actor, and then I can print string work with overlapped actor. And once I've done this, I've already established a communication because now my third person character is just sending a message. It's calling it. It doesn't even know who is going to receive it. But my work player has found a way to know my player and become friends with my player, my third person character, and is binding to it. So it's like whenever this guy calls this event, let me do something. So if I do a gameplay now, and then let me make it full screen. Then I go ahead to overlap. The same thing gets called again because, like, I don't know whether you saw that. Let me go to my work player and make this thing 10 seconds like I did before. So a communication has been established because it this that event is always listening for this. So once it can know this guy has been called, the player has called. Hope this is not a crash. I hope my energy has not crashed because my energy crashes a lot. So once it knows that, okay, that wasn't a crash. So once it knows that, oh, this has been called, this guy has been listening for this particular event to be called. So it has attached its own event to it that can be called when it is called. Sorry, I'm using called. Then this gets called, another code. So yeah, that's the basic example I can give about event dispatcher. It has many use cases. Like if you want to open multiple doors, so the player does not need to know those doors, right? But it does need to know the player that is opening them. So you can have a door, a player just create an event dispatcher called open door, and every door out there can bind to the player, and once the player opens them, then they can respond. Oh, and the door that you have opened. So it's that straightforward with event dispatcher. So it's also advised for you to use event dispatchers. Although the use case is not as obvious as that of the blueprint interface, but it's still very, very useful. And yeah, I should just finalize my slides. So I've done the demo to showcase each blueprint communication, although I didn't do a deep dive because of time, but I did something very, very brief. And I hope there's some basic understanding there. I think on your own, you can go ahead to look further into it and understand it more. There's a lot more you can do with those three. And those three are very, very powerful tools. You need to do a lot of interactions in Unreal and use the features Unreal Engine has given to you. And so that's the end of my slide. I don't think I have time for questions. I need to jump on some other things very, very soon. But I'll be in Africacomicade Discord server. Probably there's a channel for this particular workshop. I'll be there and responding to questions as many as possible. So thank you so much for your time and for following through to this point. Yeah, thank you. Yeah, I mean, like